Okay, so now it's time to look at conservation of momentum in 2 dimensions. All of the questions in grade 11, no matter which semester you had it, all of the conservation of momentum questions were one-dimensional. The object or the car or the cart or the ball or whatever it was came in, smucked the second one, and they went off in straight lines along the same line. But that's not real life. Real life is that one object goes off one way and the other goes off the other. Think of playing billiards or pool, right? They always go off at angles. And so grade 12 physics is all about 2-dimensional collisions. Okay, but don't stress. They look just like 1-dimensional collisions, except that we're going to apply the law, because remember it's a law. We're just going to apply it in the x direction and then in the y direction, because this guy would have a component v1 final x and a component v1 final y. And this guy would have a component v2 final x and v2 final y. And so in this unit, we will use m1 v1 initial x plus m2 v2 initial x will equal m1 v1 final x plus m2 v2 final x. And I can't tell where the edge of my sheet is. And we will use m1 v1 initial y plus m2 v2 initial y equals m1 v1 final y plus m2 v2 final y to find our missing velocity, the components of our missing velocity, and then we'll just do Pythagorean theorem to get whichever one it is we're missing, whether it's the 2 or the 1. It'll just be Pythagorean theorem. Okay, so maybe the easiest way to do this is with an example. So our object 1 is a 3 kilogram object, and it's rolling to the right with an initial velocity v1 initial of 4 meters per second. It collides with the stationary 2 kilogram object, so v2 initial is 0. After the collision, the first ball moves off with a velocity of 2 meters per second at an angle of 36.87, imagine, degrees clockwise from its original. So here's the original direction. Clockwise will be down. So this angle here is 36.87 degrees. And this is the first ball. So this is number 1. So this is V1 final. If number 1 goes down, you're pretty safe betting the house that number 2 is going to go up. And this will be V2 final. So we can find, maybe, this is 2 meters per second. So we can find our V1 final x and our V1 final y by using trig, and then using the conservation of momentum in the x direction and the y direction, we can get our V2 final y and our V2 final x. Okay? And then from that we can get our V2f and our theta. So doing this, starting in the x direction, m1 v1 initial x plus m2 v2 initial x equals m1 v1 final x m2 v2 final x. This guy goes to 0, and we're looking for v2 final x, so bring this one over. So it'll be m1 v1 initial, and it's all in the x direction, right? There's no angle here. So I can actually drop my x because the v initial is just completely x, minus m1 v1 final. Now the x component here is the adjacent side, so it should be cosine theta, equals m2 v2 fx. I want the v2 fx alone. Don't break it down into cos theta because you don't know it's theta, so leave it as just v2 fx. Divide both sides by the m2. Whoops, I said m2, so I wrote it 1f cos theta. Divide it by m2, and now fill in your numbers. So v2 fx equals 3 kilograms times 4 meters per second minus 3 kilograms times 2 meters per second cos of 36.87 divided by, it was 2 kilograms. Punch this in your calculator and you should get a V2Fx of 3.6 meters per second. Okay, so that's the first component. Now we need to do the y. So in the y, m1v1 initial y plus m2v2 initial y is equal to m1v1 final y plus m2v2 final y. So now look initially. This guy is still 0 because he wasn't moving at all. But what is v1 doing initially in the y? Nothing. So this also goes to 0, right? The first ball is only moving in the x. The second ball isn't moving at all. So neither of them have a component in the y direction initially. We're looking for v2fy. So bring this guy over and it'll become negative. m1v1fy is equal to m2v2f. We want the v2f alone, so divide by the m2. Okay, and when you do that, so you get v2fy will equal negative m1 v1f, and the y component is the opposite side, so it's sine theta. So the one you know you need to change to sine or cos, divided by m2. So v2fy equals negative, it was 3 kilograms, I believe, yeah. And its final was 2 meters per second. The angle was 36.87, I just went off my sheet, divided by 2 kilograms, I think. And you get a v2fy of 0.6, 1.8 divided by 2, 1.8, I think. 1.8, oh, and it's negative meters per second. What does the negative mean? It means in the opposite direction to number 1. So opposite number 1, ball 1, which in this case actually means up because 1 was going down. So now we have our two components. So now we draw them. So we have our v2fx of 3.6 meters per second going this way, and opposite 1, and 1 was going down, so this guy's going up, and it's 1.8 meters per second. So we can square these, add them together, and take the square root to get our v2f, and when we do that, I think we get 4.0249 meters per second, but we also need an angle. So you could do, you have opposite and adjacent, so tan theta is equal to 1.8 over 3.6. Do it, get inverse tan, and you get theta to be 26.55 degrees. So up here, it's 4.0249 meters per second at an angle of 26.55 degrees. Now which way? This, the x direction is your original, and so it's coming off counterclockwise. So CCW original. Okay, because in the question I did not tell you east or west or north, so you can't say like north, whatever. All right? So your questions that I want you to do now for homework are like this, and they're going to be on page 509. Okay, so you're going to do momentum in the x, momentum in the y, and then do your triangle, find the resultant in the angle. Okay, for each of the three for homework. All right, very good.